Hi, welcome to HowToStats.com. In this video I'm going to be performing a MANOVA in SPSS. Now, a MANOVA is probably one of the most complicated statistical analyses that can be performed in SPSS, and I suspect a lot of people approach doing a MANOVA with a certain amount of trepidation. I'm going to create this video in such a way to try to allay that trepidation, because I'm going to go through the main features of a MANOVA and explain them in as easy a way as I can. So here are the data that I'm analyzing. I've got 9 dependent variables here, and they're all intelligence subscales. So 3 verbal intelligence subscales, 3 memory subscales, and 3 spatial intelligence subscales. And I've got 1 independent variable with 3 levels, and it's education level. I've got undergraduates, master's students, and PhD students. And the hypothesis is that these 3 groups will differ in intelligence, and presumably PhD students are going to be the smartest, master's students are going to be the second smartest, and university undergrads are going to be the least intelligent, although they're supposedly going to be above average. So to do this analysis, we've got the 9 dependent variables that we're going to have to combine into the MANOVA, and hopefully if we get a significant effect on that using the first approach to doing MANOVA, we will then carry on to do a series of one-way ANOVAs, and for those one-way ANOVAs that are significant, we carry on to do a series of t-tests or post-hoc testing. So here is how you do the first way of doing a MANOVA. Go into Analyze, General Linear Model, and multivariate, and then take all your dependent variables and put them into the dependent variable list, and put education into fixed factors, or whatever the name is for your independent variable. This is only a one-way MANOVA. I'm not doing a factorial design where you might have 2 independent variables or more. This is really just a simpler case. Go into Options, and as a minimum, you'll need descriptive statistics, estimates of effect size, and homogeneity tests. Now, some people also look at power. In my opinion, that's not very informative in this context, but people do it, and I'll click on it. The other options are relatively esoteric, and arguably you won't get a huge amount of information. Because I want to keep this video to a manageable size, I'm not going to go into any detail with these other options. But these 4 main options, you should get enough information for your purposes the vast majority of the time. Now for post-hocs, in case I get a statistically significant MANOVA effect, I'm going to put my independent variable, because I want to test the differences between means, the comparisons between undergrads and masters versus PhD, and PhD versus undergrads across all dependent variables that are statistically significant. I'm going to choose LSD because if you've convinced yourself that the MANOVA protects you from committing a type 1 error in the event of a statistically significant MANOVA F value, then choose LSD. It's the most powerful way of finding statistically significant effects once you get a significant MANOVA and ANOVAs. So I'm choosing LSD. Some people might choose Tukey's and other options. I don't want to do a full post-hoc analysis or examination of the various post-hoc methods. I'm going to use the simplest. It's basically t-tests across the comparisons for 2 means. Now I'll click on Continue, and I'm going to click OK.